Yeah, 2 notes. I was like, that's
Hi everybody.
Where did it go?
So I wanna start by passing back the most recent test and talking about those for a moment. So kind of before I do that, I want to say, talk a little. Feel like I failed you guys a little bit. The performance, wasn't great. Now, there are individuals that did really well. Class average in the 50s. So we're gonna do we'll do a makeup assignment involved with this to earn some points back and make this, I think more representative of your abilities. But I want to pass these back, give you a chance to look at things, talk about the place where I saw the biggest problems, talk about what this makeup assignment format will look like. And today is going to be a little bit of a wanting to straighten out some misconceptions and trying to build a better foundation, because it's clear that I didn't do a good enough job on this. The test scores by and large were reflective that we didn't have a good understanding of kind of what to do algebraically. So that's on me. We'll make that up for you guys a little bit, and kind of try to straighten out what's some of the misconceptions going on. Okay. So there's no. I didn't even bother with the curve on this because I think that it needs more than, the scores were such that I think it needs more than a curve. Now, there are students that got, 80s and 90s and stuff and did, I think, quite well. Some of us were fine. A lot of us had the same major issues in specific location that we're going to spend some time today kind of clarifying and practicing and trying to clean up those skills a little bit better, because they're not going to go. Okay? Yeah.
Well, that's like yeah, less than 30. Look at that, it's all red. Yeah. Right? Wow. Right. I got multiple choice right. Not 36.
It wasn't good.
Dang, I got a multiple choice.
Let's just say I got 10 off.
Wait, but I didn't get on this.
On the what? No.
Wait, so what is this stutter?
Just a plug?
Okay. Yeah.
It was each one choice 2 points.
Hey. Okay.
Correct.
Wait.
Agents, they beat this.
Oh, that's setting up.
I swear, it looks like that.
All right. So the place where I'd like to focus, the place where I saw the biggest issues were in like do-it-yourself problems. They're not multiple choice, they're not free response, but like here's some integrals, do these integrals. Where I saw, a lot of students I think really struggle in that area. So I want to talk a little bit about the types of problems that were in that section and the approach that we want to take for each one of these different types of problems. And we'll kind of go forward from there. Is everybody okay with that plan? So in that calculator section, when you look at the integral problems in there, they're basically boiled down into 4 different types of integral problems. Now there's the most basic type that could be done with just the antiderivative formulas. No algebra was really needed. Like you distribute the integral through, you pull off some constants, you apply the antiderivative formula, you add your plus c and you're done, right? There are ones where you had to do some algebra first to simplify your expression, and then you got it to a point where you could do your antiderivative formulas and no problem. The third situation would be u sub, where like the only way through this was with a u sub. It was a required piece of the problem. And then there was that weird absolute value question that almost nobody had a good idea of what to do with. And we'll talk about how to deal with an absolute value of a function. Is everybody okay with this idea?
Yeah.
Okay. So I'm just going to kind of write up some examples on here, and we'll kind of go through them together, and then we'll talk about how you guys can earn some points back for the test scores. Sound good?
Yes.
So something like this can be done with just like our antiderivative formulas only. So if you look at this, first thing I see is a bunch of addition and subtractions, right? So I would start by distributing my integral symbol through, and I'm going to pull any constants I have along the way out to the front of that individual. Everybody okay with my initial first step? So I'm going to now look at these each one at a time, because they're now all separate problems, right? Do I know the antiderivative of e to the x? E to the x. So that piece is done. Do I know the antiderivative of secant squared? Tangent x. Again, you guys should have those stone cold memorized. Like, one person should not be hesitantly saying this. We should all be saying it in unison confidently. Like, we should know these antiderivative formulas, like, instantaneously. You should be firing these off on me. No hesitation. No, like, I hope he doesn't call on me looks. Like, if you're not there with them, make that a priority, because they're not going to go away. You need to have them. The more confident you are with that memorization and having those at your fingertips, the better this stuff goes, the better it's going to feel, the more confident you'll be, and that tends to carry forward into stuff that's maybe even, not instantaneously easy, right? Into the more difficult things if you're feeling good going through there. Antiderivative of the square root of x.
2x to the 3 x.
Great. That's wonderful. Again, Lucia thought about that as x to 1/2, and then applied the appropriate antiderivative formula. Cosecant, or the antiderivative of cosecant x cotangent x. Now that's a product there. Does that matter? No, because that is one of our antiderivatives that we should know. So negative cosecant cotangent x, its antiderivative is cosecant, right? So we have a negative here. You could think about it this way, or you could think about it the way we have written. Either way, you need to end up with like plus cosecant x at the end. Doesn't matter to me whether you think about it as plus and then the negative inside the integral, and that thing is cosecant, or the negative sign the way I wrote it, the antiderivative of that is negative cosecant. Either is okay. You're going to end up at the same spot. And then lastly, what does this thing have to have? Plus c. Lucy, I saw a hand.
I was just wondering, are all of these on the quiz that we took earlier?
Maybe? I think so.
Yeah, they are. Okay.
Does everybody feel okay? So again, there were, I think, 2 or 3 of these in the whole, or in the test were just straight, like, you could do the entire problem with just your antiderivative rules. I think one of them was like a long one like this. It was like a 6-pointer. I think it was an indefinite, or it was a definite integral where you had to plug stuff back in at the end. But if you got the antiderivative correct, you've gotten 5 out of 6. The plug is 1 point or whatever. Everybody's okay here?
Yeah.
Okay.
Would this be a no calculator program?
This isn't the calculator part. What we're talking about are these integral problems from the calculator part. Next problem I'm going to give you is one that requires algebra before we can get to our antiderivative rules. So there's going to be some kind of algebraic simplification that has to happen here in order for us to kind of proceed. So the first thing I'm going to notice is that, again, I have a sum or difference thing going on here, right? What's that going to allow me to do? Distribute the integral. I'm going to turn this one problem into 2 separate problems. Okay here. Now this is a quotient, right? The only quotient that I have an anti-differentiation formula for are those very specific, inverse trig ones and then 1 over x. This is neither of those. Hopefully it's really easy to see that, right? What am I going to do? So I'm going to think about this as this, right? And then this is going to reduce down to everybody feel okay there? Is there anything I can do with this at the start, and if I don't algebra? Can I U-sub it or anything? I can't get away with it. I can't fix this any other way. There's no way around it. Have to algebra this. Okay? Must be simplified to proceed. Brooks.
If you took the denominator out and just did 1 over x times that, would you get the same answer doing it that way?
Absolutely not. You'd be in a lot of trouble because you don't have a good product
So then how would
antiderivative rule.
How would you know then that to do it like that instead of like taking the divided by x out and not doing the natural log?
Okay, so this is an important, I'll get back to this. We saw a lot of this. The product, an integral of products is not the product of integrals. Never. Cannot do that. That is wrong. They'll be wrong every time. It's no credit. This is not a rule you can do. Ever. Okay? Two things multiplied together. I can't take the integral antiderivative of them separately. Cannot do that. Same thing goes for quotients. Cannot do this. 0 points. No credit for these whenever I see this happen. Okay? Saw it on several tests. Lots of us did this or equivalent of these things, where we tried to take a product or a quotient because we weren't sure what to do and look at the pieces separately. Cannot do that. Does that help?
Yeah.
As to why you would never want to do what you're suggesting?
Yeah.
So this, to deal with the product of two functions, the antiderivative of that, is really difficult. You probably has to be a u sub or integration by parts, which we haven't even talked about yet, as a technique to get through that. Or it may be something that's completely intractable and can only be done as a definite integral with your calculator. Because there will be problems on the AP exam where they are not possible to do by hand, where they expect you to use your calculator to just grind that thing through and be done with it. Okay? The problems I gave you, all doable by hand. Nothing required the graphing calculator. So these 2 points, like going forward, I want to just really emphasize. Derivatives, antiderivatives, do not distribute across multiplication or division. Doesn't work that way. Okay? You saw the same thing for derivatives, right? You had a specific rule, product rule, and quotient rule to handle these situations, right? We'll see later, integration by parts is our way around, is like our reverse through a product rule. Some of them, anyway. It's a more difficult process than the product rule was. And then there is no antiderivative corollary to the quotient rule. Okay? So going back to this, what am I going to do with cosine times tangent? It's the same thing, right? If the product of two functions, what am I going to do here? What's that? I heard somebody whisper. It is just sine. How did you do that? Absolutely. 100%. Everybody feels okay? And then once you've done the simplification, just your regular antiderivative rules can handle everything that you're making, right? Everybody feel okay there? Yeah. So to do a U sub, what is our Q? Composite, right? We need a composition of two functions is typically our indicator for U sub. Oops. Did I put a plus C up here? Okay, good. So let's, yes sir?
What does that mean, a composite of two functions?
so that there's function composition going on. I have like one function nested inside of another, like g of f of x. Is that okay?
If there was just two things multiplied by each other, would that still count as like we reduce a use of?
Possibly, but one of them better be a composite. Is that okay? All right. So first thing, what do you notice here? I see a sum. What am I going to do with the sum? Distribute it, make it into two problems, right? Now, when it comes, like test time and you're worried about time, you don't need to like spend the extra effort or burn the extra time of like rewriting a problem to show this. I'm doing this, trying to help you guys in terms of like, what am I seeing when I look at this? What am I processing? What am I doing in my head? This is a step where you could conceivably do this in your head. It's just like, okay, there's a sum. I can look at the two terms separately as two separate problems. I'm going to write it down for us now. If I look at the first problem, what do I see in here that would indicate that this is a u-sub problem?
2x.
2x. That's a function inside of sine x, right? Is everybody cool? Okay. So for my u, what do I pick?
2x.
2x, the inner part of the composition. Then I take the derivative of u with respect to x.
2.
Oops. Okay. Now if I look over here at my leftovers, I have no 2, right? The only leftover I'm going to have is the dx. So I want to get the dx by itself over here. So I just multiply both sides by dx and divide by 2. Everybody's okay there? So I'm going to have that, actually. And, yeah. I'll put you down here. Okay. And we'll get to that guy in a moment. Let's look at this piece. Do I see function composition here? Yes. What's the inner function? X squared minus 5. So probably that should be my u. Then I derivative with respect to x. Now if I look at my leftovers, that's the u sub piece. What are my leftovers? X dx. So that's what I want by itself. So I'm going to divide the 2 over and multiply over the dx to get the x dx by itself. Does that feel okay? So now when I make my sub in, I'm going to have e to the u du over 2. Looks good so far? Now that I've completed the substitutions, I'm ready to just apply antiderivative formulas. So the 1/2 can come out front. What's the antiderivative of sine u?
Negative cosine u.
What's the antiderivative of e to the u? Okay, we have a plus c. Am I finished? No, what do I still need to do? I have to put the u's back in, right? My final answer should have no u's in it. And I'm done. Does that feel okay there? Notice I used 2 separate substitutions on this. That's fine, right? No big deal. Is this helping in terms of like clarifying some of this stuff? The fourth type of problem was, what if I had an absolute value? So this has to be a definite integral problem. I can't expect you guys to do a absolute value that's an indefinite integral. Always has to have a bound on it because the answer needs to be a number. Now, you could type this into your calculator, but what's what I'm going to ask you to do on the points back assignment? Give me the exact value. So, is the calculator's approximator is not going to do a good enough job to give you the exact value that we're looking for here. So you're going to have to be able to do it by hand. Everybody's okay? So, what does an absolute value do to a function? Only though if it's negative, right? So like the absolute value of f of x is going to equal f of x for all x where f of x is greater than 0, and it'll give us negative f of x for all x where f of x is less than 0, right? That's kind of our piecewise definition for an absolute value. So when I see an absolute value here, what I'm going to need to do, if I have like, if I know f of x is equal to 0 at c, where c occurs in between a and b, I'm going to then go, okay, I know I'm going to have to break this integral into pieces, right? Because I need to take the part where f of x is negative and make it negative f of x, and the part where f of x is positive and just leave that as positive f of x in my integrals. So let's say that f of x is less than 0 on the interval from a to c. So what I would say then is my integral from a to b, the absolute value, f of x dx is equal to the integral from a to c of negative f of x dx plus the integral from c to b of positive f of x dx. So I have to chunk it, right? The negative piece, the entire interval where the function is negative, needs to get a negative sign in front of it. All the intervals where it's positive, need to have positive signs in front of it, and I can drop the absolute value. And now it can turn into like just a normal antiderivative problem. Let's do this with a specific function. Yeah? Okay. Oops. Okay. I recognize here that I have a absolute value. Everybody agree? So my first order of business is to figure out, is that function negative anywhere on the interval from -4 to 5? To do that, I'm going to set it equal to 0. What are my solutions?
Plus or minus 3.
Good. So I get -3 or +3. Both of those lie on my interval, right? So I'm going to make myself a sign diagram. And I'm going to pick some values and see if I'm getting where the function is positive or negative. Now, can anybody look at this and tell me where it's positive and negative? Because you should all be able to do this. Now take a moment and think about that if that wasn't super clear why that was going to be the case. What does the graph look like? So parabola that opens up. Where should it be below the x-axis? In between the two zeros, right? In between -3 and +3. Now you had a calculator for this section, so you could have graphed this problem to look at it, but I think it was a linear function anyways, where it was going to be like pretty trivially easy to deal with. Everybody okay with this? All right. So from -4 to -3, the function is positive. Everybody agree? From -3 to 3, it's going to be negative. So I'm going to do minus. And then from 3 to 5, it's going to be positive. Is everybody okay with how I chunked that out?
It's like the example that you made on the number line.
Exactly right. Yep. And it's pluses in front of the positive pieces, and then negative in front of the negative piece. Okay? Antiderivative of x squared minus 9, that's easy, right? That's just straight up antiderivative rules. And then we evaluate that from like -4 to 3. And the nice part here on this is it's the same antiderivative for each piece. So I don't even have to really think about it. And then I just do my plugins and subtract, and it's some computation, but like the calculus part is done. You know, if you can get to this, it's usually smooth sailing. That's the hardest part.
Will they give you an absolute value on integral that's not linear?
It's not.
What's the float on the
No, you can't do that. I would have no clue as to what to do with that. So I'm sure that they would not give it to you. Do we feel better about what we'd be looking for here and how to identify what to do?
Like after that.
No, yeah, I mean you have to plug the numbers in and do the subtraction and stuff. But like this is going to boil down to just a number. I skipped the arithmetic at the end here.
Okay.
Is that okay?
I think so.
What's up?
Can they give us this problem? Is it going to be a multiple choice?
I would assume that this could land either place, to be honest with you. I don't think it would be as complicated. I don't think the numbers would be as nasty as what I've given you here. My suspicion would be like, this would have gone one of two ways. Possibly they do this, which simplifies the problem a little bit, because you can, just do 2 times, like that integral, which allows it to be a little bit neater, because you get the 0 at the end, and you don't need as many breaks. Or the function on the inside would be something simple. Where it's like, now the arithmetic is way easier. And there's only 2 chunks instead of 3, and the arithmetic is simple. And if it was a no calculator, I'd expect something more like this than like that. Because they're just the fraction